Hello students, and welcome to our lesson on proportions. Proportions are what is going to allow us to solve problems that involve ratios more than anything else. And some of these you're going to notice we actually already tackled using equivalent fractions in the past, but solving them in terms of a proportion is just really it's going to be a different method that in a lot of cases ends up being easier. And so this is really going to build on what we talked about with equivalent fractions back in topic 7, but don't let that get you too in the weeds. We can also treat it as a standalone lesson and pretend that you didn't know that fraction stuff from before. But if it made sense earlier, then you're ahead of the game, and this one won't be so bad. So starting off, what is a proportion? And of course, I used the wrong color right away. Let's go with blue here. A proportion is an equation stating that two ratios or fractions are equal to each other. So we're going to have something that looks like a fraction equals a fraction. A over B equals C over D. Fraction equals fraction means it's a proportion. Proportions are often used in scaling with maps, scaling recipes, and just finding rates that coincide with each other. So again, referencing back to equivalent fractions, we talked about how 36 miles per hour would be the same as 72 miles per 2 hours. Okay, but we can actually set up a proportion to prove that those things are equal to each other instead of just thinking about them as equivalent fractions. We'll see that in just a second. Important thing that's going to allow us to solve things today is the fact that cross products in proportions also must be equal. So if you multiply across, which means a, the top of one fraction times the bottom of the other, a times d, and then you go the other direction and you do the bottom of the first fraction times the top of the other, so b times c, those values are going to be equal to each other. And real quick, I'm going to show you on the side why this works out to be true. So if we start with a over b equals c over d, and we don't use a cross product, we could instead multiply both sides of this equation by b, and that would allow us to isolate a on the left side. So when I do that, the b's on the left side would cancel each other out and just give me a. And on the right side, the b would multiply times the c on top to give me c times b on top and just d on bottom. But then if I wanted to get rid of that fraction, I could multiply both sides now by d to get rid of the denominator on the right side. The d's would cancel, and we'd end up with d times a on the left and c times b on the right, which is equivalent to doing the cross product. So cross multiplication, or finding that cross product, is really just a shortcut for what I showed you on the right in 2 steps. All right, so now first couple examples. We're just going to show that cross products are equal for each of these proportions. Number 1, we have 2/3 equals 4/6. We should know that those are equivalent fractions. But if we go ahead and multiply across, 2 times 6 is 12, and across the other way, 3 times 4 is also 12. So the fact that 12 equals 12 tells us that that proportion originally was valid. For number 2, 1/2 equals 5 over 10. We know that these are equivalent fractions, so we can multiply. By the way, notice this time I'm doing it the other order first. I'm doing 2 times 5, which is bottom times top. That's 10. And then I'm going to do 1 times 10, which is also 10. So that cross product is also equal. But I just wanted to do it in the reverse order there to show you it doesn't matter if you do top times bottom and then bottom times top, or you do it in reverse. By the way, if you saw what I drew there, this is sometimes referred to as the butterfly method, because when you do these circles here, it kind of looks like a butterfly. But official term, cross products. Number 3, I put this one in there because it looks a little bit uglier. You can't immediately tell that these are the same, that these are equivalent fractions, but the cross product will prove it. 9 times 16 is 144. And if we multiply 2 times 72 the other direction, we also get 144. So 2/9 is equivalent to 16/72. So now to solve proportions, we're going to do exactly what we just did. To solve a proportion, use cross multiplication. Then we're going to solve the resulting equation for the unknown variable. So in number 4, we have x minus 1 over 6x equals 4 over 9. You don't need to look at this and try to turn the left side into the right side. I don't even know how you would do that in this case. Instead, we just cross multiply. Now be careful, because we have x minus 1 on the top of our fraction. We're going to multiply that by 9, But when we do that, we have to distribute the 9 to the x minus 1. So it's not as simple as just doing 9 times x. We have to distribute that 9. For the other direction, we have 6x times 4, where technically we still have to also distribute the 4 to the 6x, but because there's no addition or subtraction in the middle, it's a lot easier. So we end up with, on the left, 9x minus 9, and on the right side, 4 times 6x is 24x. All right, so now we just have a normal two-step equation that we can go ahead and solve. We don't have any constants on the right side, so I'm going to leave that minus 9 where it is, and I'm just going to go ahead and subtract 9x from both sides. When I do that, I end up with negative 9 equals 15x, so then I can divide both sides by 15, and all I have to do is reduce this fraction. Instead of writing x equals negative 9 over 15, top and bottom there are both divisible by 3. So we end up with negative 3/5. Negative 3 over 5 is our new fraction as our answer. Number 5, we have 5/3 equals x plus 3 over x minus 3. You could try to come up with a number that makes x plus 3 over x minus 3 look like 5 over 3. That's craziness though, because that might be a very, very challenging number to come up with, as you're going to see when we get to the answer. So instead, we cross multiply. And again, we got to be careful with distribution. When I do 5 times x minus 3, I need to put that x minus 3 in parentheses and distribute the 5. When I do 3 times x plus 3, same thing. X plus 3 in parentheses, because we need to distribute here. The distribution on the left gives me 5x minus 15, and on the right side, 3x plus 9. Now we just have a two-step equation. I'm going to go ahead and subtract 3x from both sides to get all the x's on the left side. That leaves me with 2x minus 15 is equal to 9. Now I'm going to add 15 to both sides to get all the constants to the right side. That leaves me with 2x is equal to 24. And then I just have to divide by 2, and I come up with my answer that x is equal to 24 over 2 is going to give me 12. Hey, maybe that wasn't that hard of a result, but let's go ahead and see. That gives me 12, so if I plug 12 back in, on top, 12 plus 3 is 15. On bottom, 12 minus 3 is 9. So we have 15 over 9. And hey, that does reduce to be 5 over 3. So we didn't do too bad there. All right, moving on to number 6. 2x minus 5 over 3 is equal to x minus 5 over 7. I'm going to multiply the 2x minus 5 by the 7, where again I have to distribute that 7. And on the other side, I'm going to multiply 3 times x minus 5, where I have to distribute that 3. On the left, the distribution gives me 14x minus 35. And on the right, the distribution gives me 3x minus 15. Now, I want to keep my variable term positive, so I'm going to subtract the 3x from both sides. That way I can get all my x's on the left. This leaves me with 11x minus 35 is equal to negative 15. Notice, by the way, how similar number 5 and 6 look in terms of my solution. Nice stacked pancakes, and essentially the exact same steps that we're doing on both of these here, even though the original problems looked pretty different. One had 5/3 on the left, so no variable, and number 6 here has variables on both sides. So it doesn't matter. Either way, when we cross multiply, we end up with a pretty nice looking equation in most cases. All right, so we're down to 11x minus 35 equals negative 15. I can add 35 to both sides here. That leaves me with 11x is equal to 35 minus 15 here is going to give me 20. So then I divide both sides by that 11, and I end up with my solution, which is that x equals 20 over 11. All right, moving on to the next page. Now we're going to talk about units. And this was something that, again, I referenced in that visualizing fractions lesson, but we're going to dive a little bit deeper into it now. So when we set up proportions with units, the units are actually going to help guide us on where everything should be placed. So we want to always write ratios so that the units are in the same position on both sides. So for example, if we're comparing miles to hours, then both ratios should have miles over hours equals miles over hours. Miles on top in both spots, hours on bottom in both fractions. Okay, we could also do hours over miles equals hours over miles, but notice that again, the units are in the same spot. That really is the key. So for number 7 through 10, we're just going to set up the proportions. We're not going to solve them. We're going to be doing solving in the next section, but I just want to make sure that we get the hang of where to put things in these proportions. So number 7, we have a car travels 180 miles in 3 hours. How far can it travel in 5 hours? So it's saying how far, which means we are solving in this case for x miles, where x is going to be how far and miles is the unit. So what I want to do is set up proportions where I can solve for miles. My first proportion is 180 miles in 3 hours. So I'm going to write 180 miles on top and 3 hours on bottom. Notice that looks like miles per hour, where it's miles divided by hours. Now on the other side, I want to have miles on top and hours on bottom. To make this extra clear, I'm going to write those 3 hours in red here on bottom. Okay, so my hours unit is red and my miles unit is blue. On the right side, I don't know how many miles, so that's where I'm going to put my x miles. But I need miles on top to match miles on top of the left side. On bottom though, it says 5 hours, so I can put my unit of 5 hours down below. All I'm going to have to do then is cross multiply, and I can solve for the number of miles. Number 8, a recipe uses 2 cups of rice for 6 servings. How many cups are needed for 15 servings? So it says how many cups, so we're solving for x cups. What I want to do is write a proportion where x cups is going to be in the numerator, and down below that is going to be the number of servings that x cups corresponds to. In this case, 15 servings. So now on the left side, I'm just going to write a fraction that has cups on top and servings on bottom. So it says 2 cups of rice for 6 servings. So in the numerator, I'm going to write 2 cups. And in the denominator, I'll put the number of servings, which was 6. Notice I'm writing the units every time because that's the key thing we're lining up. Number 9, a map scale shows 1 inch equals 25 miles. How many miles does 7 inches represent? So I'm trying to solve for x miles here. So when I write my proportion, I want x miles on top. That's what I'm going to find. And it's corresponding with 7 inches on this map. So I just need to set this equal to a ratio that has miles on top and inches on bottom. So notice it gave me 1 inch equals 25 miles, but I'm not going to write 1 inch over 25 miles because that would be reverse of how I want my fraction. Instead, I'm going to put 25 miles on top to match the fact that miles is on top of my other fraction. And I'm going to put 1 inch on bottom. Now I have miles over inches equals miles over inches. And when I cross multiply, I could solve that one nice and easily. Number 10, a medicine requires 5 milligrams per 20 pounds of body weight. How many milligrams for a 60-pound child? So it says how many milligrams. So I'm going to write x milligrams, xmg. And I'm going to write a fraction that has xmg on top and the corresponding weight, 60 pounds in this case, on bottom. So then on the other side, I just need to write a fraction that uses the units in the same place. So I have 5 milligrams per 20 pounds. So I'm going to write 5 mgs on top and 20 pounds on bottom. So the key to the setup is just make sure your units match on both sides. All right, now we're going to solve some very similar problems to these one we just saw, but we're also going to have a few more complicated ones mixed in here. So first one isn't too bad at all. A map uses a scale of 1 inch to 40 miles. If 2 cities are 3.5 inches apart on the map, how far apart are they in real life? And in real life, we're talking about in miles, okay? So we're solving for x miles. So I'm going to set up a proportion where I have x miles on top of one side, and that corresponds with 3.5 inches, our problem says. Now on the other side of my proportion, I just need to make sure that I use miles and inches in the same places. So in this case, I have 40 miles corresponds with 1 inch. So I put 40 miles on top, 1 inch on bottom, my units match. So now when I cross multiply, 40 times 3.5 is 140. Notice when I cross multiplied by right now, I'm ignoring the units and I'm just multiplying the numbers. And then when I cross multiply by the other way, 1 times x is just 1x or just x. So I get x equals 40. And then now I just need to make sure that I found the thing I'm actually solving for. So on the right side, I wrote x miles on top. So x here is representing a number of miles. So we can go ahead and clarify that 3.5 inches is going to correspond to 140 miles, where 140 miles is the actual answer we were looking for. Number 12, a nurse needs to dilute a medication. The nurse mixes the medication with water to create a 1 to 5 concentration, where it's 1 medicine to 5 water. How much water was added if the total mixture is 12 milliliters? So we are solving for how much water, and it gave us the tip at the end here that we're using milliliters. Okay, so we are solving for x milliliters of water. And we are told that the total here, okay, the total is 12 milliliters. We're not told that the amount of medicine is 12 milliliters. We're told the total is 12 milliliters. So the two things I'm given here are x milliliters water, and in the bottom of my fraction, I'm going to put 12 milliliters total. So when I set up the other side of this fraction, I can't just write medicine over water or water over medicine because that wouldn't match anymore. Instead, I need to make sure that my other fraction also has water on top and total on bottom. So when I look at what I was given, it's a 1 to 5 ratio. And so if I rewrite that kind of down below here, that means 1 medicine to 5 water. So 1 medicine to 5 water, well, what's the total if you add those together? The total would be 6. Okay, 1 plus 5 gives me that 6. So when I set up my new proportion here, I know that the 5 is representing 5 milliliters of water. But again, I can't put 1 medicine on bottom because that wouldn't match. Instead, I need to put 6 milliliters total on bottom. Now it becomes nice and easy to solve by cross multiplying. 5 times 12 gives me 60, and 6 times x just gives me 6x. If I divide both sides by 6, I get that 10 is equal to x. And all I have to do then is look up at what does x represent? It's milliliters of water. And so this tells me that the amount of water that was added to the mixture is 10 milliliters of water. So out of that 12 milliliter mixture, 10 milliliters are water. Notice that that would mean there's 2 milliliters of medicine. So we have a ratio of 2 to 10, which is the same as 1 to 5. So everything stayed consistent there. Okay, a couple more of these. Number 13, we have that a photo measuring 4 inches wide is enlarged, so the new width is 10 inches. If the original height was 6 inches, what is the new height? So our new height is going to be measured in inches. So x inches, and I'm going to call it tall because we're talking about height and width. So I'm going to use tall for the height. So it's x inches tall is what we want to solve for. So I'm going to write x inches tall on top of one of my fractions. And then we have to compare this to something. So the new height is x inches and the new width is 10 inches. Okay, so I'm going to put new with new in this fraction. X inches tall is going to go over 10 inches wide. Okay, so new width is 10, new height is x. We don't know what it is yet. And then on the other side, our original height was, our original width was 4 inches wide. I'm actually going to underline that one in red, 4 inches wide. And our original height was 6 inches. So I'm going to put the 6 inches tall on top because I have inches tall on top on the right side. And I'm going to put 4 inches wide on bottom. Where notice I had to, like, inches wasn't good enough. I had to say what those inches represent in order for these units to line up properly. So on the left fraction, this corresponds to the original photo. The original photo is 6 inches tall and 4 inches wide. The right fraction is the new photo. It is 10 inches wide, and I'm trying to figure out how tall it is. When I cross multiply here, 6 times 10 is 60. 4 times x just gives me 4x. If I divide both sides by 4, I get that x is 15. So this tells me that the new photo is 15 inches tall. So that one, a little bit more complicated, right? We had to take into account that it's not just inches. That's not good enough. We need to describe the units better to be able to line up the proportion properly. All right, number 14. A recipe calls for 3/4 cup of sugar for 8 servings. How much sugar is needed for 12 servings? So it's how much sugar is our question, and it's measured in cups according to the beginning of the problem. So we're solving for x cups here. So I want one fraction to have x cups, and it's cups of sugar technically, but x cups on top and 12 servings on bottom. And then on the other side of the fraction, we know that it's 3/4 cup to 8 servings. So I just have to make sure I set it up as cups over servings and cups over servings. Now when I multiply, 3/4 times 12, well, 12 divided by 4 is 3, and times 3 gives me 9. Okay, so 3/4 times 12 is 9. And then 8 times x is just 8x. If I divide both sides by 8, I get 9 over 8 is equal to x, which means that I need 9/8 cups of sugar for those 12 servings. And if we check if that makes sense, 3 over 4 is really 6 over 8. So we went from 6 over 8 cups for 8 servings to 9 over 8 cups for 12 servings. And that actually checks out, right? Because to go from 8 to 12, I would multiply by 3 over 2. And if I multiply 3/4 by 3 over 2, it does in fact take me to 9 over 8. So you can always fall back to solving ones like this using equivalent fractions like we did in lesson 7. Because if you're ever unsure about your answer, especially for something that's a fraction, might feel a little awkward solving for it, just put it back in there, see if it works out. Okay, 2 more here. Number 15, a patient's dosage is based on weight. We have that 5 milligrams of medication per 2 kilograms of body weight is recommended. How much does a patient weigh if they are correctly given 125 milligrams of medication? So it's how much does a patient weigh? And this is measured in kilograms. So we're solving for x kilograms. And we're given that they had 125 milligrams of medication. And our other ratio is 5 milligrams to 2 kilograms. So we're going to set up a proportion with x kilograms on top and 125 milligrams on bottom. And then on the other side of this thing, we have 5 milligrams is equal to 2 kilograms. So now what just went wrong? Does everybody see it? So color coding wise, this looks great, but the colors don't represent the units. They're supposed to, right? It looks like blue over red equals blue over red, but look at what I made blue and what I made red. I have 5 milligrams over 2 kilograms, so milligrams over kilograms, but then on the other side, it's kilograms over milligrams. This doesn't work, okay? So just because the colors match doesn't mean the problem matches. If we switch the colors to where they should be, kilograms was meant to be blue, milligrams is meant to be red, so we should have that 2 kilograms is on top and 5 milligrams is on bottom. I did that on purpose here just to point out that you need to double check. When you set these things up, we need units to match units. When we cross multiply here, 2 times 125 is 250, and 5 times x is just 5x. When we divide by 5, we get that x is equal to 50. And since X represents kilograms of body weight, we have that the patient would weigh, or the patient weighs 50 kilograms. All right, one more of these. A factory produces 120 parts in 8 hours with 6 machines running. If the factory adds 4 more identical machines, how many parts can be produced in 8 hours? So let's be clear that it's relevant here that the times are the same. And what I'm going to do after we solve this one is I'm going to change that and see that it does make the problem slightly more confusing, but still very solvable. So what we are actually solving for here is how many parts. So we want X parts, and we know that we have 4 more machines. So originally we had 6 machines. So that means now we have 10 machines. Okay, so we went from 6 up 4, so now we have 10. And originally we had 120 parts. So because the hours are the same, it makes this problem easier. We're going to set it up as X parts on top with 10 machines is our new total of machines when we added 4 on bottom. And on the other side, we're going to have the original 120 parts, and that was for 6 machines. So when we cross multiply here, 120 times 10 is 1200, and 6 times x is just 6x. Dividing by 6 on both sides, we get that x is 200. And so that means that we can do 200 parts in 8 hours. Okay, so in that case, not too bad. But what if it didn't say 8 hours? Okay, so let's solve the same problem. But let's say, what about in 4 hours? And what I mean by what about in 4 hours is the whole setup's the same, but let's pretend that this second 8 is a 4. Well, then our proportion is actually going to have fractions in it. And there's always multiple ways you can set these up, mind you. But the way I would set up this question, if it said a factory produces 120 parts in 8 hours with 6 machines, and the factory adds 4 more identical machines, how many parts can it produce in 4 hours? I would write it as parts per hour divided by parts per hour. Or it's not divided by, but parts per hour divided by machines on one side and parts per hour divided by machines on the other. So what I mean by that is we would still be solving for how many parts. So I would still want to know X parts, right? But it's X parts now in 4 hours. Okay, and on the other side, we're going to have that it was 120 parts, and that was happening in 8 hours. So on one side of this thing, I have parts per hour, and on the other side, I have parts per hour. But that would only be the setup if we were using the same number of machines in both cases. Okay, so if we were using 6 machines in both cases, we would just cross multiply that one and we'd be done. But we're not. We're changing the number of machines. So what I just wrote down is actually the numerator on both sides. And then we're going to divide this by the number of machines. So 6 machines on the bottom of the left and 10 machines on the bottom of the right. So it's parts per hour per machine equals parts per hour per machine. So now watch what happens when we cross multiply with this thing. We have 120 over 8 on top of the left, and I'm going to multiply it by 10. Okay, when I do that, I'm going to leave it as a fraction. So the 10 is going to multiply times the 120 on top. That is going to give me 1200 over 8. Okay, 120 over 8 times 10 is 1200 over 8. And when I cross multiply the other way, 6 times x over 4, I get 6x over 4. But notice, I still have a proportion, so I can do it again. If I cross multiply now, 1200 times 4 is 4800, and 8 times 6x is 48x. If I divide both sides by 100, I get that 100 is equal to x. And so that would mean 100 parts in 4 hours. Now notice something. When we solved it originally, the Original problem, we got 200 parts in 8 hours. When we changed the time frame, we got 100 parts in 4 hours. Notice that it's half the amount of time and half the amount of parts, which makes perfect sense. So, a little bit more complicated how we set it up, but it works out to be the same thing. Had we wanted to do it a different way, because mind you, there's a lot of ways you could do this one, we could have done the way we did in part one to get how many parts 10 machines make in 8 hours. We could get 200, and then we could convert 200 parts in 8 hours to blank parts in 4 hours. And when we solve that one, it would give us, again, 100 parts in 4 hours. All right, maybe I had a little bit too much fun with that last problem, but hey, what can you do when you're a math nerd other than geek out over math? Hopefully you guys had fun, and I will see you in the next one.